All right, guys, we're going to talk about stars today and a little review. We've talked about all these before, but just to keep you up to date. So we can classify stars in three ways. We can classify them according to their size, their temperature, and their brightness. Okay, in size, they can go anywhere from dwarfs to supergiants. For temperature, the coldest stars are going to be red. So temperature and color are directly related. So the coldest stars are red, and then we go orange, and then we go yellow, and then white, and then blue is going to be the hottest. Okay, so it's kind of opposite of how we usually think when we think of red being hot and blue being cold. It's a little inverse. And then we can also describe stars according to their brightness. Now there's two specific words we need to get used to using when we talk about brightness. Brightness and size or magnitude are directly related as well. So we talk about apparent brightness or magnitude, and absolute brightness or magnitude. Okay, apparent is qualitative. Okay, qualitative, meaning that it's just how it looks, how it's observed, how it seems from our viewpoint. All right, so it's how big it looks or how bright it looks. So, for instance, it looks to us like our sun is the biggest star out of the entire universe. But that's not true. Our sun is just a very average star. It looks so big because it's so close to us, okay? Absolute brightness or magnitude is a quantitative measurement. So it is based on a true measurement. So we use absolute brightness or magnitude as our baseline is our sun. So our sun has a magnitude of 1 sol. So if you see something that is 500 sols, that means that it's 500 times larger than our sun. Now, all of these characteristics can be described on an HR diagram. So here's our HR diagram. And how we use the periodic table in chemistry to talk about the characteristics of elements, we use the HR diagram in astronomy to talk about the characteristics of stars. So on the y-axis of an HR diagram, you can have your brightness, or since brightness and magnitude are directly related, you could also have your size here. On your x-axis, sometimes they'll put color, and sometimes they'll put temperature, but those are directly related. So either way, you have the same information. So at our origin for brightness or size on the y-axis, we're going to have dim or small. And farther away from the origin, they get hotter and, sorry, not hotter. They get brighter and larger. Okay, now on the x-axis is inverse. Okay, so our hottest is going to be here at the origin and our coolest is going to be out here. So again, if you had your colors on here, you're going to have your red way down here and your blue here, your white, and then we'll have our orange and and yellow. And then our white here. So there's also a couple of different areas you need to be able to identify. So the hottest and the dimmest are going to be down here at the bottom, and these are white dwarfs, okay? They're small, they're dim, but they're very hot. Up here in the top corner, we're going to have our red giants, okay, because they're cool and they're big. And then up even farther than that would be our super giants. So if you had a supergiant here, it would be an orange supergiant. Our blue or white supergiants are going to be up here in the left-hand top corner. And those are our hottest and brightest. And then this area that runs horizontal all the way through here, not horizontal, diagonal all the way through here, this is where we find all of our main sequence stars, which remember is about 90% of all stars. And our sun, if we were going to look at our sun on an HR diagram, it would be a yellow star just smack dab in the middle, because remember our sun is a very average star. Another interesting thing to look at on the HR diagrams, you can actually track the life cycle. So all stars go through main sequence. The stars that have a lower mass than the supergiant, so the ones that start out with the lower mass will go from main sequence to giants and then down to white dwarfs. Whereas the ones that have the initial high mass will go through main sequence, go to supergiants, maybe even to blue supergiants, and then following their supernova, they either create black holes or neutron stars. So depending on the initial mass, you can also track their life cycle.